Mathematics has its own language, most of which we're very familiar with. For example, the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 are part of our everyday lives. And whether we refer to this digit as 0, nothing, naught, or O, as in the telephone code 0191, we understand its meaning. There are many symbols in mathematics, and most of them are used as a precise form of shorthand. We need to be confident using the symbols, and to gain that confidence, we need to understand their meaning. To understand their meaning, we've got two things to help us. There's context. What else is with the symbol? What's with it? What's it all about? And there's convention. And convention is where mathematicians and scientists have decided that particular symbols will represent particular things. Let's have a look at some symbols. That sign, words associated with it, a plus, add, increase, and positive. As it stands, it has some form of meaning, but we really need it in a context. For example, 2 plus 3, or 2 add 3, we know the context, we add the two numbers, and we get 5. Let's have a look at another context. Now, if you'd gone abroad, say to Europe, and you'd gone to a conference, you might hand out some business cards. And on your business card, so that people could contact you, you might have your telephone number. And chances are it will be written as plus 44, and let's have a phone number 191 123 4567. And in this context, that plus means that the person dials the necessary code for an international line from their country, then 191 123 4567. So it still means in addition to, but not in the same way as that plus sign. We're not actually adding the number on, we're doing it in addition. Let's have a look now at this sign. Words associated with this one are minus, subtract, take away, negative, and decrease. And again, we need a context. Let's 6 take away 4, or 6 subtract 4, and we all know the answer to be 2. In a different context, if we have minus 5 degrees C, for example, that means a temperature of 5 degrees below 0. How about this one? Words associated with this symbol: multiply, lots of, and times. Now this one is really just a shorthand for adding. Let's have a look at a context. For example, 6 add 6, add 6, add 6, add 6. What we've actually got are 1, 2, 3, 4, 5 sixes, and in shorthand we want to write 5 sixes, and the symbol that's used is the multiply sign. So we've got 5 lots of 6, or 5 times 6. Now this shorthand becomes even shorter when we use some letters instead of numbers. So for example, instead of 6, let's say we were adding A's. And again, we'll have 5 A's. But because we've used a letter, if we use the multiply, it could be confused with the letter X. So we don't write it in. Basically, we miss it out and we just write 5a. So the shorthand becomes shorter. So when letters are involved, the multiply sign is missed out. It's the only symbol that we miss out. Let's look at division. Now this symbol can actually be written in 3 different ways. We could have 10 divided by 5, 10 divided by 5 as it's written in a fraction, or 10 with a slash and 5. Now this one's come about mainly because of printing and typing and using a computer when these symbols are not readily available on the keyboard. So how many times does 5 go into 10, or 10 divided by 5? Another very common symbol that we use all the time without thinking is the equals sign. Again, it doesn't mean anything on its own. We need it in some form of context. So if we have the sum 1 plus 2 equals 3, what we're saying is whatever we have on this side is exactly equal to whatever we have on this side, or it's the same as. Variations on the equals sign are the not equals sign, a line through the equals, which is not equal to. For example, x is not equal to 2, so we know that x does not take that value of 2. 2 wavy lines without equals means approximately equal to. So it may not be exact, but it's approximately equal to that value. Our greater than or equals sign. An example here might be x is greater than or equal to 2. That means x could take the value of 2, but it could be any number larger than 2. And our less than or equal to. And here, for example, y could be less than or equal to 7. Y could equal 7, but it could be any number less than 7. And an easy way of remembering which is the greater and the less than part is the greater is the wider part of the symbol. Whatever's on the wider part of the symbol, whatever's on that side, is the greater than the one where the point is on the other side. Other forms of mathematical symbols are variables. And these are used where things take different values. For example, imagine your journey to work in your car, and imagine the speed that you're travelling at. As you go along your journey, your speed will change. So we might refer to the speed with a letter. Let's say the letter V, because throughout your journey, the actual numerical value is changing. We usually use letters for variables, letters of the alphabet. You can call them anything, but we try to use letters of the alphabet, and we try to have those letters giving us some indication of what our variable is all about. For example, we might use D for distance and T for time. By convention, we use U to be initial speed and V to be our final speed. But of course V might also refer to volume. And this is where context is important. And we look to see what a variable is with as to what it might mean. So for example, if we were to see V is d divided by t, and we're told that d is distance and t is time, then we know that that v is speed. Whereas if we saw v with 4/3 pi r cubed, where r is the radius of a sphere, we know that that v is also the volume of a sphere. Now, going back to our example again of our journey to work, we might want to record the time it took us to go to work. And we might want to do that over a number of days. The most sensible variable to use would be a t for our time. But of course, if we want to record it for each day, how do we distinguish between the t's? Well, in this case, we use a subscript. So for day 1, we might use T1. The next day, T2, T3, T4, and T5. Or we might want to be a little bit clearer and actually put perhaps TM for the time on Monday, TT for Tuesday, TW for Wednesday, we'd have to do TH for Thursday, so it doesn't get confused with Tuesday, and TF for Friday. So we can use these subscripts, small numbers or letters, at the bottom right of the variable to distinguish between them. Now, by convention, mathematicians have decided that we're going to use some letters of the Greek alphabet for some of our mathematical symbols. For example, we have pi. And pi has been chosen to equal the number 3.14159, and it goes on and on forever, never repeats itself. And so that we can precisely say what we mean, rather than having to round the value, we use the letter pi, knowing that it's that number. From the Greek alphabet, we also use some other letters, such as alpha, beta, and theta. Now, these are often used as variables to represent angles. So you might see an angle marked in that way, and the Greek letter theta. Another one that's commonly used is a capital sigma. Now, you should be familiar with this one from any spreadsheet program on a computer, because you'll find it somewhere on the toolbar, because it means the sum of, and it's a shorthand for adding up a column or a row of numbers on a spreadsheet. So it means the sum of. The positioning of where we put letters or figures with our symbols gives meaning to it. Just like our subscripts, we can have superscripts. Now, superscripts, instead of going at the bottom right, go at the top right. So, for example, 4 with a little 2 at the top right-hand side. That's a superscript. And again, it's a shorthand, as most of our symbols are. And that means 4 squared, or 4 multiplied by 4. If we have 4 cubed, we've got 3 of them, 4 times 4 times 4. All right? A number there means to the power of. So we've raised 4 to the power of 3. 4 times 4 times 4. 32 with a 0 as a superscript. Now this has actually got two meanings, and we need the context to be able to know which meaning it is. It could be 32 degrees, and that would mean an angle of 32 degrees. But it could mean 32 to the power of 0, which is actually 1, which is a very different meaning to an angle. So you need to know the context to be able to decide which one it means. Staying with our superscript, we could have 32 degrees again, but this time with a capital C after it. And that would mean a temperature of 32 degrees Celsius. Let's have a look at a couple of numbers now. It could be 6, 3, or it could be 63. Let's put a little bit more context there. If I put a comma between them, then I know it's not 63, but I'm still not sure what the meaning is. It could be a number of things. But if I then put brackets around it, I know straight away that it's a pair of coordinates. And what it represents is the position 6, 3 on my coordinate axis. So I would go 6 in the x direction, 3 in the y direction, and that is the position that that coordinate is representing. Now brackets may be used in a different way. If, for example, I saw a P and brackets h equals a half, I know that's actually nothing to do with coordinates at all, and that is most likely to be probability. And that is saying the probability of event H happening is equal to a half. I don't know what that event is. I could surmise that it could be the probability perhaps of scoring a head when I toss a coin is equal to a half. But I don't know. I'd need more information. But certainly that it's something to do with probability. Another symbol we use, the percentage symbol. This is familiar to us because here we've got our divide sign, and this means out of 100. So if we have, for example, 90%, it means 90 out of 100. Let's look at a few more symbols. For example, our square root sign. An example here might be the square root of 16, and it's the number that when we multiply it by itself gives us 16. So the answer could be 4, or it could be minus 4, because minus 4 times minus 4 gives us 16. Now often in printed material you might just see the square root as just the tick without the line across the top. If you're writing it, it's clearer if you put the line across the top to include, so it's clear what you're including in that square root sign. But be aware that you might just see the tick sign. Another symbol that's used is an X with a bar across the top, and it's said X bar, and it means the mean. So it's the mean of a set of numbers. Instead of writing the word mean, we write X bar. Another symbol, let's say we have 1.3 and we see a dot over the 3. And this is our recurring decimal sign. And what that means is we've got 1.3 and 3, 3, 3, 3, and it goes on forever and ever, recurring. So the dot over the decimal place means it goes on forever. We might have 1.317, for example, and dots over the 3 and the 7. Similarly, it means it goes on forever, but what it means this time, slightly differently, is that it's the 317 that's repeated and goes on forever. In summary, mathematical symbols are a precise form of shorthand. They have to have meaning for you. You need to understand them. And to help with that understanding, you have context, what else is with them, and you have convention, which is what mathematicians and scientists have decided certain symbols will represent. And that's all you need to know.